So what this question 4 says. So in this question 4, this is a question related with force and couple, force moment system. So in this question, a metal girder AB has a weight of W newtons and length is 6 meters. The girder rests in a horizontal position on two supports C and D, where AC is equal to dB is equal to 1 meter, as shown in the figure. So we have a girder, the girder AB, and its weight is also noted it as W, and its length is 6 meters. Now, what is our question? When a force of magnitude 900 Newton is applied vertically upwards to the girder at A, the girder is about to tilt about the point D. So here the key word we have to utilize for doing this question is this. What is that? When a 900 Newton is vertically applied at A, what happens? What happens? The girder is about to tilt about D. About to tilt about D. Similarly, when a force of magnitude 1500 Newton is applied vertically upwards at B, what happens? The girder is about to tilt about C. So please mark or consider these two key points to do this question. Okay, the girder is modeled as a non-uniform rod. So what is the meaning of non-uniform rod? If it is a non-uniform rod, their center of mass is not acting exactly at the center. So what they are saying, the center of mass is at a distance of x meters from A. So find the value of x. So we will do this question as two separate. We will approach this separately. So I will, separate these two portions. I'm going to do this question in such a way that, okay, I will use a different color. So I just separated this session and we are going to approach this question separately. So this is my girder and we have two beautiful supports. What are they? One is this. So these are the two supports. Okay. So these two supports will give a support reaction. This is A and this is B. This is C and this is D. So definitely a support reaction RC, and there is a support reaction RB over here. And apart from this, a weight is acting. A weight is acting downwards, right? So whose weight is W, since its rod is not, girder is not uniform, it is x distance away from that. I will also mark the distance. So this distance, the distance between W and A is x. This is 1 meter. Even this is also 1 meter because altogether 6 meter, right? So this has to be 4 meter, right? So that is a scenario, or that is the aspect. We marked all these distances. And in the first case, there is a force of 900 Newton. There is a force of 900 Newton is acting upwards. A 900 Newton is acting upwards. So due to that, what happens is a 900 Newton is acting upwards. So due to that, what happens is this is going to tilt. This is going to tilt. At which point? About D. So since due to 900 Newton upwards at A, it tilts about D. So due to that reason, we can instantly put what? RC as 0. Okay, so if this is tilting about D, RC becomes 0. So this is very important. This we learned in force and moments in mechanics. So if you are considering about a point D, if you are tilting, the other support reaction, you have to consider it as 0. So we can go for equilibrium equation. The total force in the vertical direction is equal to 0. That means 900 plus RD is equal to, because we are not interested to consider RC, right? And that is equal to W. Or if you're making RD the subject, it is W minus 900. So value of RD, we got it as W minus 900, equation number 1. So this is actually case number 1, okay? Case number 1. So continuation. Continue case 1. Then we will take total moment about any point as 0. For instance, here I'm taking total moment about B is equal to 0. This is another equilibrium condition, right? So 900 times the perpendicular distance, the total distance is 6, right? 900 times 6. It is it's clockwise moment. It is actually clockwise moment, right? So 900 times 6, 900 times 6, then minus this W times B. So what is that distance? Could you please try to calculate what is that distance? This is X, therefore altogether 6, that means it is 6 minus X, right? So W times 6 minus X, then this RD times 1 is clockwise. So RD times 1 is equal to 0. So if you are simplifying, 900 times 6 is 5,400 minus W times 6 minus X plus RD is equal to 0. And we already calculated RD in terms of W, correct? So if you are substituting that, what happens? 5,400 minus W times 6 minus X plus W minus 900 is equal to 0. Because I'm replacing the value of RD. Okay, so replace RD as W minus 900 from equation number 1. Am I correct? So if you're substituting this, what happens? 5,400 minus 6W plus WX. I'm expanding the bracket, okay? Plus W minus 900 is equal to 0. So 5,400 minus 900 is 4,500. Minus 5W minus 6W plus W is minus 5W plus WX is equal to 0. Or 4,500 minus 5 plus X times W. So this is a plus here, is equal to 0. That implies W times x minus 5 is equal to 4,500. I'm just rearranging this. So this is equation A. Okay. So this is equation A. So from the first case, we got an idea that W times x minus 5 is equal to 4,500. Now we will revisit the second case. Now we will revisit the second case and disrupt this unwanted workings. So in the second case, so this is a case 2. So we'll redraw the figure, correct? So this is my the figure. So this is 2 supports. Am I right? This is RC and this is RD. And this is 1 meter. Even this is 1 meter. Its weight is acting downwards. That is not changing. That means the distance between this and this is x. So this is A, this is B, this is C, this is D, and this is a point where the weight W acts. Now, here, what happens is, in the case 2, we will read once again. When a force of 1,500 Newton applied, so this is actually case 1, right? This is our case 2, 2 separate cases, correct? So when a force of magnitude 1,500 Newton applied vertically upwards to the girder at B, the girder is about to tilt about Z. So about to tilt at which point? About to tilt at C. So here we are applying a force of 1,500 Newton. 1,500 Newton. So due to this 1,500 Newton, it is about to tilt at the point C. So here at that time, RD becomes 0. Since it tilts at C, RD becomes 0 due to 1,500 Newton at the B. So same scenario works. What is that? The total vertical force is equal to 0. That means W is equal to RC plus 1,500. Or RC is what? Is that W minus 1,500? So that is equation number 2. Then take moment about any point. So I'm taking moment about A because make sure that while taking moment, try to include RC in that moment. So I'm taking moment at the A because my aim is to, eliminate this RC. Moment about A is equal to 0. So that means 1,500, right? So 1,500 times 6. Am I right? 1,500 times 6. So that is anti-clockwise. Then W times X. Then this RC times 1, that is anti-clockwise. And that is equal to what? 0. So that means minus 9,000 plus WX minus RC is equal to 0. So what is RC? We have already calculated. So minus 9,000 plus WX minus of what is RC? W minus 1,500 is equal to 0. If I'm expanding this, what happens? Minus 9,000 plus WX minus W plus 1,500 is equal to 0. If I'm simplifying this, minus 9,500 plus W times X minus 1 is equal to 0, or W times x minus 1 is equal to 7,500. So we simplified this beautiful equation. So we developed another equation. What is that? W times x minus 1 is equal to 7,500. So I will put it in a box. W times x minus 1 is equal to 7,500. So that is what? That is equation B. What is our question? What is our question? Find the value of x. So here we are in a position to find what is the value of x. So here we are in a position to find the value of x. So we developed two simultaneous equations. What is the first equation? From this equation A, w times x minus 5 is 4,500. Equation B, w times x minus 1 is 7,500. So now what we are doing? We are dividing equation A over B to find the value of x. So w times x minus 5 is 4,500. W times x minus 1 is 7,500. So we are dividing this stuff. So W got cancelled. These two zeros got cancelled. So eventually it becomes x minus 5 over x minus 1 is equal to this. If you are simplifying with the 15, it becomes 3 over 5, right? So it becomes 3 over 5. So cross multiplying, 5 times x minus 5 is equal to 3 times x minus 1. So 5x minus 25 is equal to 3x minus 3. Then find it. Find the answer, please. Then you simplify this and find the answer. Okay, so while doing the equation number A, while simplifying, I made a small mistake. The mistake is, so if you're making w into x minus 5, it should be minus 4,500, because if you're bringing 4,500 to the other side, it becomes minus 4,500. So while dividing, it should be minus. So here you have to put a minus. So it becomes what? Minus 3 over 5. So this is minus 3. So 5x minus 25 is equal to minus 3x plus. And if you're rearranging this, if you're bringing to the side, it becomes what? 5x plus 3x is equal to 3 plus 25. So 8x is equal to 28. For x is equal to 28 upon 8. So that becomes 3.52, approximately 3.5 meter. So the answer for this question is 3.5 meter. So the value of x is 3.5 meter. So that's the idea. So please, be very careful while bringing the terms to other side, because if you are missing that minus, the answer will be wrong. Okay, so this is minus 4,500 according to our equation. So that's it. So that's the idea about this question. Next question is purely about vectors. Particle is acted by two forces F and G. The force has a magnitude, the force F has a magnitude of 8 Newton and acts in a direction with a bearing of 240 degrees. The force G has a magnitude of 10 Newton and acts due south. Given that R is equal to F plus G, that is the resultant, find the magnitude of R. The direction of R, give your answer as a bearing to the nearest degree. Okay, fine. So in this question, first of all, we have to draw a schematic sketch. So this is our north and south direction. This is north. This is east. This is south. And this is west. And we know that bearing always measures from the north. A particle. So this is our particle. Particle P. So that is being affected or acted by two forces, F and G. So what is the speciality of F? The magnitude is 8 Newton and acts in a bearing of 240 degrees. So somewhere here. So we are going to show the bearing. It's 8 Newton, right? This is force F. And its magnitude is 8 Newton. And it is 240 degrees. 240 degrees. So this is 240 degrees. Then the speciality of S. The speciality of S is what? It is acting, not speciality of S, I mean the speciality of G, has a magnitude of 10 Newton and acts due south. So we will mark that as well. So that is our G. The modulus of G, that means its magnitude, is 10 Newton. Since it is due south, this is acting on the due south, 240, the bearing of this stuff will be 180 degrees. So what is the difference between this 240 and 180? That is actually the angle between F and G, right? That's common sense. We can use our common sense. Am I correct? So here, this angle, the angle between F and G, that is 240 minus 180, that is going to be 60 degrees. Are you able to correlate? Now, what is our question? Now, what is our question? Our question is, we are in a position to find, it is given that resultant is F plus G. According to our basic idea, R is actually the resultant, parallelogram law of F tradition. Did you remember? Yes. So F plus G is the resultant. So they are asking about that value, modulus of R. What is modulus of R? Okay. So what is the formula? If you know the angle between, suppose, right? If you want, you can write a note. If two vectors we have, if A and B, then if this angle between them is theta, and if its modulus is modulus of A, and its modulus magnitude, I mean, the magnitude of A and B are represented by modulus, then the resultant is something like this. The modulus of resultant is calculated by the formula modulus of A whole square plus modulus of B whole square plus 2 times modulus of A times modulus of B cos theta. The same thing works here. So modulus of R is equal to root of modulus of F square plus, that means modulus of G square times 2 times modulus of F modulus of G cos theta, and that is equal to root of 8 square plus 10 square plus 2 times 8 times 10 cos 60. So please calculate this value. What is the answer? Substitute these values in your calculator and find it. So I'm also inputting these values. 8 square plus 10 square plus 2 times 8 times 10 times cos 60 and take the root of that. So we will get 15.6 Newton. So if you are rounding to 3 significant figures, the modulus of R is 15.6 Newton. So that is the answer of magnitude. Magnitude means it is nothing but modulus of R. So that is what 15.6 Newton. Sorry. Now what they are asking, the directions. So where is this resultant is acting? So for finding the resultant, we will use, finding the direction of the resultant. What we will use is, we will consider, or we will use the concept of parallelogram law of vector addition. So we will construct a parallelogram. So parallelogram means opposite sides are equal. So we are going to construct a parallelogram using this. So this is our parallelogram. So what is the speciality of this parallelogram? Opposite sides are parallel and they are equal. So that means its modulus is also F, right? So this is also 8 Newton. This is modulus of G, and that is what? 10 Newton. And the resultant is acting something like this. So this is resultant. And the modulus we already got. What is that? That is 15.6 Newton. So this is particle P. I'm just naming this as A, and this point I'm just naming it as B. So what they are asking about the direction of this resultant. That means the bearing. So we are in a position to find this angle. So for that, we are pretty sure that up to this part, it is 180. So if you know this angle as alpha, our answer becomes 180 plus alpha. So that is our required answer, correct? So I would like to spotlight that triangle over here. Okay. I would like to spotlight that triangle. So I will separately draw that triangle over here. So this is our triangle, correct? This is our triangle. So I would like to bring that triangle. So this is our triangle, such that this is 15.6, and this is what? This is 8, and this is 10. And we are in a position to find this alpha. Are you able to use any formula that we learned in your lower classes? Or you learned in P1 as well? What is that? Cosine rule. What? Cosine rule. So what is cos alpha? Cos alpha is equal to 15.6 square plus 10 square minus 8 square divided by 2 times 15.6 times 10. So could you please calculate the value of alpha, please? 15.6 square plus 10 square minus 8 square divided by 2 times 15.6 times 10. Then take the cos inverse of your answer. The alpha is 26.4 degree. Therefore, the direction of R is 180 plus alpha. So that is 180 plus 26.4, and that is going to be 206.4 degree. And if you are rounding to three significant figures, I would say 206 degree. So here, what is the idea? So this is our particle, right? And this is my resultant. And this resultant is acting actually what? It is actually acting 206 degree from the north direction of P. So that is the answer for this question 5B. I hope you got it. So shall we move to the next question? We are moving to question number 6. So in this question, two girls, Agatha and Brioni, are roller skating inside a large empty building. The girls are modeled as particles. At time t equal to 0, Agatha is at the point with position vector 11i plus 11j meter, and Brioni is at the point with the position vector 7i plus 16j meter. The position vectors are given relative to the door O, with the I and j are horizontal perpendicular unit vectors. Agatha skates with a constant velocity 3i minus j meter per second. Brioni skates with constant velocity 4i minus 2j meter per second. Find the position vector of Agatha at the time t seconds. So that is the first question. So here, in every mechanics questions, a rough sketch will, serve or help to do the question very easily. So similar to the previous question, we are going to draw a schematic sketch for this. This is also a question from vectors. So here, this is my x and y axis. This is x axis, and this is our origin, and this is our top. The position vector of Agatha is 11i plus 11j. So here 11 unit horizontally and 11 units vertically, right? So that we will keep somewhere here. So at a t equal to 0, Agatha is at this point. I would like to keep it as a 0. So the position vector is 11i plus 11j. Then what about Brioni? It is 7i plus 16j. 7i, that means 7 unit horizontally and 16 unit vertically. Am I correct? So somewhere here. So at a t equal to 0, Brioni is at a b0, and b0 I will write somewhere here. So this is 7i plus 16j. Now what is our question? After t time, Agatha is at somewhere other than A0, right? Because she moves with a constant velocity. So at a t time, after t time, Agathe is at AT. So now we are in a position to find her position vector, the new position vector. So how we will find this new position vector? How we will find this new position vector? So this is our question. So this was the position vector. So the position vector of Agathe at 0. So this is the position vector of Agathe at a t time. So according to the equation that we learned, the new position vector is equal to original position vector plus speed times time. Am I correct? It's 2-mark question, right? So that is 11I plus 11J plus what is the velocity of Agathe? That is 3I minus J. 3I minus J times T. So that is the answer for the first part. So answer for this first part is the new position vector of Agathe after t time is equal to 11I plus 11J plus 3I minus J times T. If you want, you can write the I terms together and J terms together. So that is 11 plus 3T I cap plus 11 minus T, because if you're expanding this 3IT minus JT, right? So 11 minus T J cap. Am I correct? So this is the answer. Now, show that at the time t seconds, Agathe passes through the point P. At time t seconds, Agathe passes through the point P. Show that Prani also passes through the point P. Find the value of t when and find the value of t when this occurs. So that means, like here is our point P. So first of all, we have to show what? First of all, we have to show Agathe. First of all, we need to find what is the position vector of Agathe at t is equal to 6. So this is actually the position vector of Agathe at 6 seconds. So this is position vector of Agathe at t is equal to 6. At t is equal to 6. So could you please calculate what is the position vector of Agathe at t is equal to 6? First of all, we will calculate this. What is the position vector of Agathe at a t is equal to 6? How? You will simply input this value as 6. 3 times 6 times I plus 11 minus 6J. So that implies is 21I plus 5J. And in the second part, they are asking us to show B will also passes through this point. So this is actually the position vector of what? This is actually the position vector of P. So we have to show the same particle. So initially the particle was, Agatha was here, and at t is equal to 6, she traveled like this. And similarly, B also traveled like this to the same point P. So first of all, you calculate what is the general equation of the Brioni after t seconds. Both general equation for or general vector equation of position of Brioni. How we will find that? So if we're considering Brioni, the position vector of B at t second is equal to RB0 plus the velocity speed of Brioni times t. So that is 7I plus 16J plus what is the speed? The speed is 4I minus 2J, right? 4I minus 2J, 4I minus 2J times t. So that implies is 7 plus 4T I plus 16 minus 2T J. So this is the position vector of Brioni after t seconds. Then how we will show that these two are equal? Since RB passes through P, we can say that RB of T is exactly equal to the position vector of P. So that means how we will show 7 plus 4T I plus 16 minus 2TJ is exactly equal to what is the position vector of P that we already calculated? 29I plus 5J. Then what we can do is a very simple thing. So we short, and for what time this is happening for Brioni. So here the coefficients, these are equal, we can equate the coefficient of 5, right? So 7 plus 40, we can equate to 29, or 40 is what? 29 minus 7, is that 22? So 40 is equal to 22, or 2 is, t is equal to 22 over 4, is that 5.5 seconds? So Brioni passes this point P at after 5.5 seconds, but Gata passes after 6 seconds. So we got the time. So that is the answer for which question? B question. So find the value of t when this occurs. So this happened at 5.5 seconds. Now, at time t seconds, Agatha is at a point A and Brioni is at the point B. Show that AB is equal to t minus 4I plus 5 minus tj dt. So here, I would like to draw one more figure. So same thing. So randomly, at any time t, so initially Agatha was at A0, right? And Brioni was at B0. Now what happened? Brioni reached somewhere here at a t time. Similarly, Agatha reached somewhere here, that is A. So here we need to find, what? We need to find what? Agatha at a t seconds, Agatha is at a point A and Brioni is at the point B. Show that vector AB is equal to this. So here they are asking about this vector A. So how we will find this vector A? So this is the position vector of A after t seconds. This is the position vector of B after t seconds. So we can easily calculate, right? So this is a position vector of B after t seconds. This is a position vector of A after t seconds. So using this aspect, we can calculate the value of vector AB. How? Vector AB, that means vector R, the position vector of BT, the position vector of BT, or position of vector of Bryony after t second is equal to what? The position vector of A after t second plus vector AB. Or we can say vector AB is equal to position vector of B minus position vector of A. So what is the general equation of position vector of B in t seconds? We have already calculated. What is that? 7 plus 40i plus 16 minus 2tj minus, what is the position vector of A? The position vector of A is 11 plus 3t I plus 11 minus t. So could you please expand it? So what happens? 7 plus 4t I minus 11 plus 3t I plus 16 minus 2t j minus 11 minus t j. So if you're expanding, what happens? 7 minus 11 plus 4t minus 3ti plus 16 minus 11 minus 2t plus t. So it becomes minus 4 plus ti plus 5 minus t. So vector AB, we simplified it as minus 4 plus t I plus 5 minus t j. Am I correct? So that's what they're asking to show, right? Let's see. Minus 4 plus t and 5 minus t. Yes, show that this has this need. We did that. T minus this, we can write it as t minus 4 into I plus 5 minus t into t. Hence what? Hence we show, right? So we are answering the A part of this question. Hence we show. It's not A part, C part, right? Hence we show. So that is the answer for what? That is the answer for C part. Then the last part, the question. Find the distance between the two girls when they are closest together. Find the distance between the two girls when they are closest together. So that means we just want to find what is that distance. Both are starting from rest, or they both are starting from t equal to 0. Then we need to find at what time this distance is closer. So for that, we will take the magnitude. How we will take the magnitude? How we will take the magnitude? First of all, we calculate what is the modulus of AB. So modulus of AB means it is what? Minus 4t, because we have the equation for AB. We need to find what is the minimum value of AB. So minus 4 plus t whole square plus 5 minus t whole square. Then we have to take the square root. If AB is minimum, then AB square is also minimum, right? So to avoid this square root, I'm just squaring both sides. So AB square is equal to what? Minus 4 plus t whole square plus 5 minus t whole square. Am I correct? Then what I'm doing is, what I'm trying to doing is, I'm expanding this. I'm expanding this. So minus 16, minus 4 whole square, that is plus 16. Then plus t square. If I'm expanding this, what happens? T square minus 8t plus 25 minus 10t plus t square. So if you're adding this together, it becomes 2t square minus 18t plus 41. So 2t square minus 18t plus 41. So that is AB square. And we know that this is actually a quadratic equation, right? So can you please write this in the completed square form? How we will write in the completed square form? T time 2, we will take 2 common from this 2 times, right? So if I'm taking 2 common, it becomes what? T square minus 90 plus 41. Am I correct? Then 2 times we will complete the square inside this. So t minus 4.5 whole square minus 4.5 square plus 40. And if you're expanding this, what happens? 2 times t minus 4.5 square minus 2 times 4.5 square. Minus 2 times 4.5 square is minus 40.5 plus 41. So it becomes what? 2 times t minus 4.5 square plus 0.5. So we got an idea. So if I'm plotting the graph of AB square, the AB square value is taking a minimum value of AB square value is taking a minimum value of, this is 0.5, right? So if I'm plotting the graph of AB square, because here this is actually the expression for AB square, right, my dear students? Any doubt? So if I'm plotting the graph of AB square, if I'm plotting the graph of AB square, so let me draw that graph somewhat like this. It's the graph of AB square. This is the graph of AB square. And it reaches to a minimum value. It reaches to a minimum value at t equal to 4.5 seconds. It reaches minimum value at a 4.6. And that value is what? That value is 0.5. So we got an idea that at a t equal to 4.5 seconds, AB square value is taking a minimum of 0.5. Therefore, what is the minimum value of AB? AB we can take as 0.5. So that is square root of 0.5. And what is that? 0.707. So the minimum value of AB is equal to what? 0.707. So that is the answer for this question. The minimum value is 0.707. Oh, I will use a different ink. I think it's not showing. It's showing clearly, right? Okay. So the one minimum value is what? If you want, I can rewrite that. So what is that, my dear students? AB square is, what is AB square? So the minimum value of AB square, the minimum value of AB square is 0.5, right? Sorry. The minimum value of AB square is 0.5. From which one? From completing square 4. We derived, right? Therefore, we need AB, right? AB minimum is actually what? It is square root of 0.5. And what is that? 0.707 meter. If they're asking also for the minimum time, and at what time it is happening, we will equate t minus 4.5 to 0, or t is equal to what? At 4.5 seconds. At 4.5 seconds. So that is the idea about this question. I hope you got it. So next question is an interesting question. A helicopter is hovering at rest above horizontal ground at the point H. A parachutist steps out the helicopter and immediately falls vertically and freely under gravity from rest for 2.5 seconds. His parachute then opens, causes him to immediately decelerate at a constant rate of 3.9 meter per second square for t seconds, and it is given that t is less than 6. Then, until his speed is reduced to 4 b meter per second, he then moves with the constant speed b meter per second until he hits the ground. While he is decelerating, he falls a distance of 73.75 meter. The total time between the instant when he leaves H and the instant when he hits the ground is 20 seconds. The parachutist is modeled as a particle. Find the speed of the parachutist at the instant when his parachute opens. Sketch a speed time graph for the motion of the parachutist from the instant when he leaves H to the instant when he hits the ground. Find the value of t. Find to the nearest meter the height of the point above the ground. So altogether, how many marks? It's 12-mark question. So we have a parachute and a helicopter. So this is a kind of helicopter. From this helicopter, a particle P, parachutist, is falling up to 2.5 seconds. So he attains a speed at this point. So this point I'm just marking it as A. The speed attained, he attained a speed of VA. Then from this point A, he again decelerates and it reaches to the point B. So his speed attained, it was B. Then what happens? Then he traveled the remaining distance and he reached the ground with the same velocity. So that means since in this region, since it's in this region is purely freely falling. Therefore, acceleration is actually g. It is 9.81 meter per second square. Am I correct? Then the initial velocity is freely falling. Initial velocity is 0. But in this A to B session, this is ground. In A to B section, he traveled 73.75 meters. The total distance between this and this point, the distance between this is h. So here it is decelerating, correct? Therefore, acceleration is minus 3.9 meter per second square, according to this question. Here he is moving with a constant velocity or constant speed. Therefore, acceleration is equal to 0. Now, we need to find first what is the velocity at this point A. For the A part, that is actually the particle starting from P and it's reaching A, right? In this session, initial velocity is 0 and the time taken by this particle is 2.5 seconds and the acceleration is 9.81 meter per second square. We can use this formula. VA is equal to U plus AT, right? Since U is 0, 9.81 times 2.5. So please calculate this. 9.81 times 2.5. So that will give 24.5 meter per second. So that is the answer for the A part. So now we got an idea. The speed is 24.5 meter per second. Now what is our next question? Now what is the question? Sketch the speed time graph for the motion of the parachutist from the instant when he leaves H to the instant when he hits the ground. So from this schematic sketch, we can easily draw the diagram. So this is speed, this is time. So we can say that the speed is increasing, and it reaches, initially it was 0, and it reaches to a maximum speed of 24.5 meter per second. So here the acceleration is 9.81 meter per second square. It's accelerating, uniform acceleration. Then what happens? So this time is 2.5 seconds. Then it decelerates up to a time t. It decelerates up to a time t. So the acceleration is minus 3.9 meter per second square. Then with the same speed he maintains and he reaches to a time 20, because altogether 20 seconds, right? So this is the speed time graph for the following data. So here acceleration remains 0. So this is the answer for B part. It should be a straight line. Okay, so you have to use a ruler. I'm not using a ruler here. This has to be a straight line. Now move to the C part. And it is given that this t is less than 6 seconds, right? Am I correct? So here we are in a position to find the value of t. So how we are going to find the value of t? So here, this T is actually, first of all, identify from which session to which session is this T. That is from A to B. The total distance covered is 73.758. And the initial velocity is VA, is 24.5 meter per second. What is the acceleration? Minus 3.9 meter per second square. So which equation we can use? S is equal to UT plus half AT square. So S is 73.75, initial velocity is 24.5 T plus half times minus 3.9 times T square. So you can bring to the other side, it becomes a beautiful quadratic equation, half times 3.9 T square minus 24.5 T plus 73.75 is equal to 0. It becomes a quadratic equation. You can solve this quadratic equation. So please solve this quadratic equation using a calculator. So one value of T, we will get it as 7.56 seconds. Another value of T, we will get as 5 seconds. Since T is less than 6 seconds, according to the question, T will be what? So this value we can neglect. Which value we can neglect? 7.56. So T value is equal to what? 5 seconds. So that is the answer for this part. Am I correct? Right? Now, find to the nearest meters the height of the point H above the ground. So that means we are in a position to find the total height. So this total height, we can split it as, a section from B to A to B, and B to H, B to G, I mean, that is ground. So here this speed, we got it as, we don't know that speed though, but is it possible to find that speed? We can find that speed, right? Okay, anyway, we can find, but the time we got it as 5 seconds. 5 seconds. So we need to find the total height, right? So this is a total moment. So this is a point B. Initial velocity is 0. It reaches at this point A. So here the speed is 24.5 meter per second. And its acceleration is 9.81 meter per second square. Therefore, is it possible to calculate this, the distance between B to A? How? B square is equal to U square plus 2x. So 24.5 square is equal to 0 square plus 2 times 9.81 times SPA. So SPA would be 24.5 square divided by 2 times 9.8. So please calculate 24.5 square divided by 2 divided by 9.8. So that is 30.59 meters. Then it reaches to the point B, and we are pretty sure that it is 73.75 meters. This is already given here. And this speed is a big question mark. How you will find that speed? VB. VB square is equal to U square plus 2AS, right? That is U square is 24.5 square plus 2 times minus, because acceleration is minus 3.9 meters square, minus 3.9 multiplied by 73, because this is distance is given, right? So 73.75. Therefore, VB would be equal to 24.5 square minus 2 times 3.9 times 73.75. 575.25. 24.5 square minus 575.25. So VB square 25. Therefore, VB is equal to square root of 25. That is 5 meter per second. It's 5 meter per second. So same speed he keeps up to his ground level. So here we can use which, since the speed remains same, speed is equal to what? Distance by time. Unfortunately, is it possible to find that time? Yes. How? From B to A, he takes 2.5 seconds. From A to B, he takes 5 seconds. And B to G, all together 20 seconds. So 20 minus 5 minus 2.5. That is, this has to be 12.5 seconds. Therefore, this time we already got. So V is 5. 5 is equal to distance divided by 12.5. So distance is 12.5 multiplied by 5. So substitute this, and that is that you will get as 62.5 meter. Therefore, the total distance. So this is our D. This is our D. Therefore, total distance is equal to STA plus SAB plus SPG. SPA, we got it as 30.59. This is 73.75. This is 62.5. So you add all the stuffs. 30.59, 73.75, 62.5. So you will get 166.84. If you're writing to the nearest meter, 167 meter. So the H value for this is 167. Altogether, we traveled 167 meter. That is the answer for this question. I hope you got it. So that is the idea about this question. So altogether, 167 meter. 167 meter. So nearest to the meter. So that answer is 167. The value is 5 seconds. This is 24.5 meter per second. So this we already did. Okay. So last question in this question pair. So we'll move to the last question of this question pair. Okay. So last question. Question number 8. So this is a question connecting with the friction and inclined plane. Two particles A and B have masses 2 kilogram and 4 kilogram respectively. The particles are connected by a light and extensible string. The string passes over a small pulley which is fixed at the top of the rough plane. The plane is inclined to the horizontal ground at an angle alpha, where tan alpha is 3/4 The particle A is held at rest on the plane at a distance d meters from the pulley. The particle B hangs freely at rest vertically below the pulley at a distance h meters above the ground, as shown in the figure. The particle of the string, the part of the string, between A and B, A and the pulley is parallel to the line of the greatest slope of the plane. The coefficient of friction between A and the plane is 1/4. The system is released from rest with the string taut. So underline the keyword taut, and B descends. Find the tension in the string as B descends. So here, so what happens is, since the B is falling down or B descends, this A particle is moving up. So that means it is a connected system and the string is taut. That means the same string is connected between A and B. If the acceleration of B is A, the acceleration of A is also A. And the same tension is available. The same tension is available for these two particles through the string. So now we are in a position to find what is the value of this tension. So for that, we will draw a free body diagram. So in this free body diagram, so we will draw the inclined plane. So this inclined plane is an angle, it's inclined with an angle alpha. This particle P, whose weight definitely is acting downwards, that is 2g, and the tension is acting in this fashion. And due to this tension, this particle is moving up. So now what I'm trying to do is I'm resolving this weight. So if this is alpha, this angle has to be alpha. Therefore, if you are resolving, this component is 2g cos alpha. This component is 2g sin alpha. So not only 2g sin alpha, also a friction is acting opposite to the tension because the particle is moving upwards, right? The acceleration is upwards. And the normal reaction is acting in this fashion. So if you're resolving, the normal reaction is equal to 2g cos alpha. And we know that according to the Newton's second law, net force is equal to mass times acceleration. So what is the net force? T minus F minus 2g sin alpha is equal to 2 times acceleration. So T is unknown, minus friction is what? Friction is mu times normal reaction. So that is 1/4, that is mu is 1/4. Normal reaction we already know, that is 2g cos alpha minus 2g sin alpha is equal to 2 times acceleration. So if you are simplifying this, what happens? T minus g upon 2, because 1/4 and 2 got simplified as g upon 2. So g over 2 cos alpha minus 2g sin alpha is equal to 2a. This is one of the equations. Then we have a mass particle B, whose mass is 4 kilogram, that is acting downwards. So 4g weight is acting downwards, the tension is acting, and the acceleration is acting downwards. So Newton's second law, we can say that 4g minus t is equal to 4 times acceleration. Or we can say what is the value of tension? Tension is what? T is 4g minus 4. Or we can say that 4 times g minus. Am I correct? So value of tension is equal to 4 times g minus. Then this is equation number 2. And we have already equation number 1 we already derived. So T minus g upon 2 cos alpha minus 2g sin alpha is equal to 2a. So in place of t, we can replace this as, in place of t, we can replace 4g minus a minus g by 2 cos alpha minus 2g sin alpha is equal to 2. See, we know that tan alpha is 3 upon 4. Therefore, alpha is tan inverse 3 upon 4. Because already that tan alpha is already given as 3 upon 4. So substitute it 4 times 9.81 minus a minus 9.81 by 2 cos of what is alpha? Tan inverse 3 upon 4 minus 2 times 9.81 sine tan inverse 3 upon 4 is equal to 2a. So from this, you try to make a the subject. So simplify this. If you are expanding 4 times 9.81, that is 39.24 minus 4a, then minus 9.81 divided by 2 multiplied by cos of tan inverse 3 by 4, 3.924 minus 2 times 9.81 multiplied by sine of tan inverse 3 over 4 is 11.772 is equal to 2. So you can bring this minus 6a to this side. So 6a is 39.24 minus 3.924 minus 11.772. 6a is 23.544. So that implies we can calculate the acceleration 23.544 divided by 6, and that is 3. So we got the acceleration as 3.92 meter per second square. So what is this acceleration help us? Because they are asking for the tension. Tension is what? Tension is nothing but we have already derived an equation. 4 times g minus. So substitute this 4 times 9.81 minus 3.9. So substitute this value. So that will give you 23.5 Newton. So that's what they're asking. The tension for this is equal to 23.5 Newton. Is that clear? So that's the answer for this question. So it carries 9 marks. So now the next question. On hitting the ground, P immediately comes to rest. So given that A comes to rest before reaching the pulley, find in terms of each the range of possible values of T. So once again, I will review this question. So what is D? Before doing this question, what is actually D? So D is actually the distance between the particle at the initial position to the pulley. So what they're asking what all values D can take. That's what their question. Okay. So we'll do this very carefully, this B part. So this is our inclined plane, and this is our pulley, and this is our mass, correct? This is 4 kilogram. And this is our 2 kilogram. So the distance the initial distance between this is our D. So this is H. So once it hits the ground, what happens? So if this 4 kilogram reaches here, I'll use a different color. to represent the same. This a 2 kilogram will move h distance. Am I correct? So this is our 4 kilogram. So this will move h distance. It's not only moves h distance, because this immediately becomes, its velocity becomes, so here we can say that after hitting the 4 kilogram, immediately its speed becomes, or velocity becomes what? 0. And at the same time, what happens? The tension on the string becomes 0, because there is a slack happens on the slack on string. That means there is no tightness it will feel, because it's already now lies on the ground. So what we will do is, we will find the additional distance moved by the particle whose mass is 2 kilogram after hitting by the mass 4 kilogram on the ground. Okay, so for the instance, I'm calling this as A, this as B. So what we are going to do, we are finding what? The velocity, or we can say it is speed for easier understanding. Speed of particle B just before hitting the ground. How we will find? Because this particle, that means for the particle B, the distance traveled is h meter. The acceleration, we got it as 3.92 meter per second square. And the initial velocity, because it's starting from 0, this initially it was 0. So we can easily find how h is equal to ut. So 0 into t plus half a. Anyway, time is unknown, right? So we can use this equation, which equation we can use. V is equal to 0 square plus 2 into 3.92 times h. The acceleration, we got it as 3.92, right? Yes. So v square. So b square. So that is actually, we call it as b. So v square is equal to 2 times 3.92, that is 7.84 h. Therefore, v is root of 7.84 h. So this is the speed of the particle B just before hitting the ground. So at that instant, this particle is being connected using a string, and that is connected to a particle A. The same speed is available for particle A. So same speed is available for particle A. What is the reason? Because just before hitting, it's connected, right? Connected by the string, correct? Therefore, we can say that at this instant, once it hits the ground, at this instant, the speed becomes what? Root of 7.4 h. Now, after hitting, what happens? After hitting, the tension becomes what? Tension on the string becomes 0, because it's slacked. So if I'm drawing the free body diagram of A, there is no tension. The tension on the string becomes 0. And its velocity is what? Its velocity is, initial velocity is root of 7.84 h. Am I correct? Since it is moving above, because it has a velocity in the upward direction. Still, this the two downward forces acts. What are they? 1/4 mu times 2 times cos alpha. Also the friction, right? This is friction, I mean. Then the component of the weight, that is what? That is 2 sine alpha. So I missed that G part. 2G sine alpha. So therefore, what is the net force? Net force is equal to minus 1/4 2G cos alpha minus 2G sine alpha. Okay, after hitting the net force on A, after hitting, and that is equal to mass into acceleration. So after hitting the acceleration of the particle A, now changed. So minus 1/4 2G cos alpha minus 2G sine alpha is equal to 2 times A. So could you please make this, we can call it as A dash. So this is the acceleration, that is A dash. So please find that acceleration. So minus 1/4 multiplied by 2 multiplied by, so minus 1/4 multiplied by minus 1/4. Oops, just a second. Minus 1/4 multiplied by 2. Multiplied by 9.81 multiplied by cos of, because alpha is tan inverse 3/4, right? Minus 2 times 9.81 times sine of tan inverse 3/4 is equal to 2 times acceleration. So please calculate that value. So please plug these values. You'll get the answer. Sine tan inverse 3/4. So you'll get minus 15.696 as 2 A dash. Therefore, A dash, the new acceleration is minus 7.85 meter per second square. So the new acceleration we got. Then you might be wondering why we calculated this new acceleration. Because with this acceleration, the particle A will move some more distance. And it is given in our question that even if the particle B or the 4 kilogram touches the ground, the particle A, I mean the particle of mass 2 kilogram, is not at all reaching to this pulley. So that means still some more distance is there after reaching, to the rest, to the pulley, I mean. So we will find the additional distance. So that means this is the pulley. This already, now it is on this, I mean, this is on the ground, this 4 kilogram. So what happens is, initially, the particle was this 2 kilogram particle was already traveled h meter, and with the acceleration, definitely this will move some more distance without tension. This is slacked. So this initial velocity is root of 7.84 h, and the acceleration is minus 7.85. Then this additional distance moved. Additional distance moved is equal to S is equal to, how you will find that? How we will find? You can use this equation. V square is equal to U square plus 2S, because in final velocity becomes 0. So 0 is equal to root of 7.84 h whole square plus 2 times acceleration is minus 7.85 times S. So what happens is 0 is equal to 7.484 h minus 15.696 S. Therefore, S is equal to 15,696 7.84 h divided by. So 7.84 h divided by 15.696. So S is equal to, if you're rounding, that is 0.5 h. So that means additionally, this is moving 0.5 h. Okay. So that means once again we will particular question. Find in terms of h the range of possible values of d. So this is the d. Okay, this is actually the d. D should be what? At least 1.5 meters should be there, because we have to accommodate h, because a is a particle that is traveling h, not only h distance, additionally 0.5 h. That means so it's already traveling 1.5 h, but still there is some distance after that to the pulley. So that means d must be greater than, if you get my logic. So we got the idea, right? So here what we will do, so we will say that since after coming to rest by the particle according to the question, still an appreciable distance remains between the particle, Just a second. Remains the particle so distance remains to the pulley. So D should be greater than 1.5 h, because already this particle A is traveling h and 0.5 h. So definitely D D is greater than 1.5. So that is the idea about this question. Okay. Now, the last part of this question paper. State one physical factor other than air resistance that could be taken into account to make the model described above more realistic. So here we didn't consider the mass of the or weight of the string, correct? So to make the model realistic, to make the model realistic, consider the weight of string. So that is the answer for all these questions. I hope you got it. So in between, if you have any questions, so suppose sometimes, some basic concepts, some students may feel, or some students may find some difficulty in understanding the same basic ideas, because some basic steps I skipped in this question paper solution. So if they need any particular clearance for any questions, please feel free to message or make a comment. Okay, so I will give you the clear idea about that. So thank you very much. So please support me. Subscribe my channel. Please subscribe my channel. Please give me likes, and please share this channel to your friends. So till then, so that's all for this today's video session. So today I'm winding up. I will come with a new solution, with a new paper. So till then, bye-bye.